Listen. My fortune.
What do we have, Captain?
We have land, Mr. Murray.
Hello, everyone, and welcome to Inside Unreal, a show where we learn, explore, and celebrate everything Unreal. I am your host, Dan Hutnick, and I am joined by some folks here who have been working on Mutable and have come and kindly agreed to do a masterclass on, believe it or not, Mutable. Before we jump into that, though, we do have a brief news announcement, which is that hotfix 5.7.3 is hot off the press with 45 updates and fixes. Please feel free to share feedback and discuss the current version of the release topic on the Epic developer community, which we'll link in chat now. If you experience a bug with 5.7.3 hotfix, please follow the How to Report a Bug guide to report it on the bug submission form. Also, as a reminder for those who are thinking of switching, UE 5.7 Linux transitioned from SDL2 to SDL3. Users with customizations to SDL2 code who are interested in switching to UE 5.7, including the new 5.7.3, should be aware that they will need to rework those changes in SDL3. With that, we've got a lot to cover here, so let's go ahead and bring in our lovely guests and throw them around the room. Let's start with Pede. Go ahead and introduce yourself. You are muted. Can you hear us, Pede? Might not be able to hear us.
No.
No.
Oh no.
Great start.
Can you?
No.
Oh,
Now.
there you go.
Now.
Yeah.
Okay,
There we go.
let's start.
Yeah.
Let's start.
So, well, let me start again.
Thank you.
Okay, so I'm Vera. I'm one of the devs behind the Mutable team. I work mainly on the runtime part and all the compiler and the cook stuff.
Perfect. And sorry.
To the next one.
Yeah. Perfect. And then Gerard.
Hi, I'm Gerard Martin. I'm also a developer at Mutable, a programmer, and I work mainly on the graph language and optimizations.
Perfect. And then Max.
Hello, I'm Max, another developer of Mutable. I mainly work in the editor and tools and user experience.
Perfect. And then if anybody's familiar with our marathon animation sample session we did, you should be familiar with Dustin. But Dustin, go ahead and introduce yourself too.
Yeah, I'm Dustin. I'm a senior technical animator on the TDR team. So I get the chance to work with all of the dev teams on animation and character stuff, as well as get to work with licensees and folks around the world on showing folks all things Unreal and characters and animation and gameplay.
Perfect. Well, I know we're here to talk about Mutable. It sounds like we have a lot to cover. For those who aren't familiar with Mutable, what it is and what we'll be talking about here, what would be a good synopsis to kind of get people up to speed?
Yeah, I've got a little presentation that if you want to kind of head it over to me and we can focus in on it, we can kind of get started on kind of the agenda and what it is. But for the most part, Mutable is a tool to do character customization in the engine, and it's got a lot of awesome features that I think a lot of folks don't know about. So that's why we're here today, to kind of show those off and give folks a chance to deep dive. So
Perfect.
if you want to share my screen, I
Let's do
can
it.
do my little presentation and we can kind of get started.
Let's jump in.
Cool. So yeah, just a quick agenda just for folks for the live stream and for, later on when folks watch this later. We're going to go over kind of what is Mutable. I'm going to dive into the Mutable sample overview, and just kind of go through our sample project that we've had that we've been updating for the past few releases. And then I'm going to hand it over to these guys, who are awesome, and to deep dive and go under the hood on some of the elements of Mutable. And then I think they're going to have a chat talking about some of the future stuff that's coming down the pipe. And then we've got some links for if you want to keep going in the future. And then Q&A at the end. So ultimately, I kind of highlighted at the beginning, but just to kind of boil it down to its bare bones, Mutable, simply put, is just a tool for customizing and merging meshes. It sounds simple, but there's a lot of things that you can do and you would want out of that feature set that Mutable offers. And it works really well with characters, vehicles, weapons. We support tons of different stuff all through skeletal meshes. But you can also use it in the runtime, which is a huge benefit for if you're doing customizable NPCs or weapons and things. Or you can use it in the editor and bake those things down. And I'll kind of show that in the sample project. Some of its key features, it allows you to do high amount of customization across a combinatorial metric of like assets. So if you have a ton of shirts, a ton of pants, a ton of shoes, it allows you to take those elements and combine them together using rules in a graph-based language that Gerard was kind of talking about to be able to define how things flow and the options that you can set for your instances. It also allows you to optimize those systems. So you can take a bunch of components, like typically an actor or character might be made up of a jacket, a head, a body, shoes, things like that. And you can combine those into one skeletal mesh component at the runtime level. You can reduce your texture count through this by atlasing and various other tools. And you can just reduce your overall draw calls. And this allows you to do it at runtime, and you can do that texture editing at runtime as well. And so it's really awesome for those character customization tool sets that you need for a lot of modern games out there. a quick overview to kind of get you into the headspace of how this kind of flows, and we'll get into the sample project, is ultimately we take a bunch of meshes, textures, and other data, um, pass it through this customizable object that has a bunch of rules that you can define. You can create instance assets, customizable instances, where you tune what you want to see, and that's what gets output to the game at the end of the day. So that kind of jump into the demo here. This is our Mutable sample project. If you're curious and you want to jump into this while we're talking about it today, just switch over here. You can get this off of Fab, download it for any version of the engine. You can add it to your library here. If you're using the Epic Games Launcher, we have our samples tab here where you can get any number of our samples, but the Mutable sample is also right here too, and you can create that sample project. If you want to do this in your engine, kind of getting started with Mutable, you need to enable the plugins. So I'm just going to show that really quick so folks are aware, because we have a couple plugins for Mutable. So if you go to the plugins tab, type in Mutable here, you'll find everything. You'll notice that the main one here, Mutable, it's a beta plugin. We went beta last release. And there's a couple others that the sample has turned on by default. That's clothing and groom. But we also have some other experimental samples for rig logic, for MetaHuman, as well as our data flow extensions, which I think is extremely new, if I remember correctly. Super experimental is what I'll say.
Yes.
But once you get into the project, this is what you'll see. And today, this level represents a lobby. It's a character customization screen with also some weapon stuff to kind of show how you can work with hard surface models. And if you were to hit play, you get a sense of what Mutable can do. So here, you can go to customize, and we have all this UI here to show you like, oh, well, I kind of want to change the color of my jacket. I want to give myself a tank top. I can change the color of that, and I can adjust the pattern as well for that, and drop an image on there. And once I'm like, I love that, I can lock that in. I can go to his weapon here, and I can swap out different weapon parts. Maybe. Are we crashing? I hope not. I have now frozen, so that's good. But nonetheless, with the sample project here, you can check that out and see how you can utilize this in that customization tool set. Dan, I think I'm going to have to restart this, so you might want to pull away here.
Yeah. Wouldn't be a live demo without something.
Wouldn't be a live demo.
Comes with the territory.
So I'm just going to restart this. But the next thing that we'll kind of go over is once you get into the sample project, it can be kind of daunting to navigate. There's a lot of stuff in here, and there's a lot of potential complexity. And my goal today, before we get into the deep dive part, is to kind of demystify it a little bit and kind of show you around the project to help you get in there and navigate it.
Yeah. That's awesome. And for folks who, are maybe new to the idea of Mutable and just kind of this sort of thing, you have the quick example of, like the character customization and things like that. Mutable is basically like the back end for that. Is that a good way to kind of describe that? So instead of having to build this all, out from scratch, you kind of got like a nice framework to work from that
That's right.
has optimizations and things like that.
Yeah, so that graph-based workflow is a really good framework to take something that can be really complex and data heavy, and put it into a format and structure that allows you to feel like you're scripting it and be able to make it easy for people to jump into that combinatorial like problem set, as well as there's a couple other things inside of here per like character options where you can say like, okay, for this jacket, I want to do this specific thing, and whatnot. So, yeah, I think we're backing up and good. So,
Right.
Cool. So the other thing that's in the project here is if you open up the content browser, when you first dive in, there's a few folders and it's not 100% clear where to start, but the main place that you want to start is here in the character folder. If we open that up, we see our first kind of asset here, which is the customizable object. So this customizable object is the basis for pretty much everything inside of Mutable. If we open it up, this is the graph and what you will see here. So I'm just gonna don't try to read this or anything. It's I'll zoom in on different parts. But this is what a typical kind of customizable object looks like. And the viewport here is split up into three kind of sections. You have your graph where you're defining all of the different mesh sections and what's happening with those things. You have your details and options over here, as well as Tag Explorer, which is a feature I think the dev folks will be able to talk about. And then over here is your preview instance, where you can kind of test what's happening inside of your mutable character with all of their different parameters that you've set and be able to test those outputs. So for example, I want to give this guy a t-shirt. You can see that. And then as a part of that, you can come up here and you can see the assets that it's actually generating in real time. That would be the same thing that you would use at runtime or bake it out, for example. This character is complex. It's one of the most complex versions of a character, but it's fully featured as well, and I think that that's really important to have in the sample. But as you kind of dive in here and start to navigate this, I'm just going to point out a few sections and nodes, but I'm not going to like do it kind of thing. But the base thing here is this your root object, and this is your output for whatever your customizable object is. And you're going to give it a name. These are the components that are going to feed into it. That's what these outputs are going to be here. Mutable also has the idea of being able to modify meshes with different functions. So in this case, this t-shirt, for example, goes over the body, and we can hide all of the mesh that's underneath for that. And that's done through a modifier, a clip mesh modifier, and there's a few types of those. Then there's the children customizable object branch here. And what this does is it allows you to create a couple different nodes, and one of them being these object groups. And what this can do is you can separate your character into logical parts if you want to, or any way that you would like. And you can associate more customizable object graphs like this to these object groups so that you can get things like a parameter here. For example, let's do pants because you need some pants. So there's a pants object group here, and now that's a option where you can choose one or none, for example, and that shows up now as a parameter that we can use in our instances. And these are all different customizable object graphs where they have their own logic for what they need to be able to display correctly with the mesh that you're going to be building. And in this case, if I choose jeans, that means that if he had shoes, for example, or boots, they are going to react to the boots or the shoes appropriately based on the rules that we define in that jeans graph. And then the last thing is Mutable does support grooms. You can see that here in our sample. These are a typical groom that you would have in Unreal. They get piped through separately and attached to the head. Going back, some other things that are in here. We've got the ability to modify our colors and textures for our skins, and this kind of touches on how you can use floats values to adjust things like your age, aged clothing, or your skin age, for example. Or you can use skin tone, which is a little bit higher up. Where are we at here? I can't remember off the top of my head. But you can also pump in textures, and you can have, a texture mapped based skin tone approach here. And as you update this, you can see it. It's right here, skin tone with the skin tone float parameter there. as well as color parameters for all of your shoes and things. And these get exported, all of these variables that we're defining in this main graph, they get exported to those subgraphs where we can utilize those variables to do things in the jacket layer or the shirt layer or whatever we want. So lastly, to kind of, before we get into the final bit of kind of showing customizable instances, I kind of want to show like the jacket, for example. So if you want to see one of those sub instances here, you have your skeletal mesh with its data. We open up the jacket, and this mesh or this customizable object just does what it needs to do for this particular jacket, which includes we take the skeletal mesh data and we can age it up. There's some variation stuff based on our if we're doing some trousers that push out the jacket, for example, or we need to do some morph targets on this to push things around based on our body style, for example. That's all defined in here. But you'll notice inside of here that where's the import? Yeah. So here's the aged clothes like float value from the main graph that we defined that property. You can import that value so that you can use it in this graph to change texture data, for example. That gets all output into what we call a customizable instance. So if we open those up, if you right click on any customizable object, you can do create new instance here. And we have one already set up for this character. And what that does is it brings up a very similar looking screen for the graph view, just minus the graph, where you can define what a character looks like. And then you can decide from there if you want to bake that instance out, for example. If you do this, it will take all of this data that we're pulling together and these the generated resources and export them to disk if you'd like. So if you don't want to do runtime and you just want to load some preset characters off of the disk for gameplay, this is how you would do that. But you can also use these customizable instances here inside of like a gameplay context and a runtime context. But some other tools that are in here are you can define the concept of states. So in this case, it's we have a gameplay customizable instance versus a like lobby or locker customizable instance that have some slightly different settings for handling streaming textures and things like that that you can define. So from there, what you get is you can do something like I showed earlier, where you can use blueprints or you can code the ability to pipe in new data to create screens like this for your customizable characters. Or as another example, if you want to have something more attuned to your needs as like an animator, for example, but you want to work with your gameplay character customizations. I have an example where in a previous job, I worked on a game that had crazy customizations where you could put on like a giant mascot helmet, for example. And we always had problems in cinematics where you're trying to make sure that the camera doesn't clip with this mascot head. So it was tough to animate against that. And now with the animation and engine tools, and with Mutable here, you can do stuff like this where I have this animation pawn that has the character set up with my animatable instance that I've made. And it's set up to draw that specific character. And if I go to that animatable instance, I've set them up to have this nice jacket and pants, and they look pretty good. And then if I go to my sequence here, where it hangs again, you're killing me. I did it. Here, let's just reconnect this. We'll reassign this actor. Okay. And I've got a control rig here where I can adjust the animation. This is a layered control rig. It's a modular control rig as well. I can adjust this animation on the fly. I'm animating against this particular character. And I can go to my instance here and I say, okay, well, I want to test what this character looks like without the jacket. I can go to the jacket here. I'll search it just to make my life easier. And I can just say none, and automatically I can just turn that off and I can continue animating. And the benefit of this, what's really cool, is that that customizable instance and the data that I'm using is the same exact one that I'm using for gameplay. It's the same one that I'm baking out, whatever I want. And that means as an animator, I am using the same, I'm not using some paper doll or anything like that. This is all the same system, and it's really, really cool.
That's amazing.
The last bit that I want to show, and then I'll hand it over to the dev team, is oftentimes if we go back to the lobby level here, we won't save that, that's okay. And if I were to hit play, there was all those UI elements that were available. Another thing that Mutable has is the concept of, this is the wrong screen, go back here. Is the concept of metadata. So I'm going to go to the jacket really quick, and we can leave it there. If I select the mesh object, oh, I forget where the metadata is off the top of my head. Oh no. Unfortunate. Oh, here it is. Parameter UI metadata. So if I select this base object, this is the output for this particular jacket. We have the concept of the ability to tie like UI elements that you can then fetch as metadata as parameters are changing from the customizable instance at runtime to populate UI data. And it's awesome for building those customization widgets where you need to have like a bunch of different tiles and things like that. As well as oftentimes when you're dealing with multiple characters of different body sizes or things like that, or you need to, you have a jacket and it needs some animation specific things like physics asset or animation blueprint data, you can also tag meshes with anim instance metadata, and that gets collated through the whole graph. And then you can grab that after you generate your character at runtime and then apply things like an animation layer for a jacket because it needs it, and things like that. So, yeah.
Just
Tons of stuff.
just saw somebody in chat just say this would have been perfect for a big animation project I just wrapped up.
Nice. Well, hopefully you get to explore it soon.
Yes, use it for the next one. Use it for
Yeah.
the next one.
But
Having
yeah.
all these features like embedded, like the metadata and stuff like that, all in one place is awesome. That's a really cool little detail.
And I think like we have some other tools available that I think the dev team can kind of talk about, but ultimately you can kind of see in this sample project that there's a lot of combinatory stuff that's happening, and we set it up in a way to kind of show how it can scale better than having, everything in one giant graph, for example. And there's some more tools to handle scale. It's a common ask. So as you get in there and explore, and also with some of the documentation we send out, you can start to get a feel for like, oh, how can I use this in my project for character customization, but I'm also like a live service product, for example, or something like that. All of those are possible with these systems. So.
Well, another little detail that I like too is this seems right from like the concept, like something that's very good for something that has a lot of customization at runtime. But the fact that there's also like you could use this just as like an in development thing for maybe something you don't have an active runtime component to, but just for like quick iteration and things like that, and then be able to just bake that out instanced wise is also really great. Like that's not a use case I would have considered probably. That's very
in fact,
cool.
I'll just kind of do that. I'll go to the weapon here. I'll open up the weapon CO, which is a little bit simpler. This is another great place if the character stuff is a little bit too much, you might be able to dive into the weapon and do some previewing type stuff. Here, I'm going to just create an instance from it really fast. There's an empty preview. We might need to look at this. But I'll deal with the character because it was working. So yeah, just a concept of kind of what that looks like. If I drop a t-shirt and some pants on this character here, and I hit bake instance, it's going to compile the CO. I wish I had done that beforehand, but and then it'll offer up a screen that says like, hey, where do you want to put these files, basically? And it'll just output what was in this generated section here with both the meshes, any new materials it creates. Yep, here we go. So I'll just make a new folder here on test output just to be fancy. And then it's just, these are all the things that it's going to output. It's going to create your material instances. It's going to create your textures. If you're doing heavy like atlasing, for example, you'll need new textures. And so you can see these here, as well as any of your skeletal meshes. I'll hit save, ruining my local sample project here. But the output.
Thank you for sacrificing it.
Oh, my poor hard drive.
Oh.
And you can see it here. You can just grab these from disk here, and you can see the output. So
That's
yeah.
really cool. That's really cool.
Cool. So I think I'm done with my part. I think that's a pretty
Perfect.
good overview. I think Pere, you're next, right? Up on stuff?
No, that will be Max.
Yeah.
Perfect.
Oh, it's Max. Excellent.
While we switch over to Max, I wanted to quickly say for the folks watching live, in the chat, leave in brackets question and then follow that by your question. If you have any questions that you would like to ask the folks as we go through here, we will be collecting those throughout the show and then throw them at them towards the end. So again, if you have any questions or anything like that, bracket, question, and bracket, and then follow that by your question. And we will gather those and ask them at the end. With that, Max, we are good if you are good.
Yeah, I'm good.
We'll do it.
Yeah. Okay, I just want to make a brief addition. The weapon, for example, it's a good example to see what the metadata can do with UI. Just for example, you can, here you have a simple details, but with some metadata, you can have a cooler one. For example, you can divide the options by sections. For example, body, colors, and decals. All this information is read from the metadata. And also you can add UI thumbnails, which is pretty cool. I just want to mention that before starting my section. Also, okay, now what I'm going to do, I'm going to try to make a brief explanation of the most difficult stuff of Mutable and the coolest one. For example, how to define the rules that the testing set of how things work, how things interact with between them, and this kind of stuff like clipping. Well, how to make a clipping when I enable the shared. So let's start. For example, I did this small example here where I have a simple body with a jacket and a shirt, and it looks pretty good. But if I remove the jacket, I can see here that the body is clipping through the shirt. So let's fix that. The way that we can do that is with these nodes, which are called modifiers, which basically we have a bunch of them. These modifiers basically modify, as the name says, modify mesh sections. And I'm going to explain how they communicate because they communicate through tags. For example, in this case, this is the object that defines the shirt. And I want to say that when I enable this shirt, I want to clip the mesh section of the body, which is right here. So how do I do that? The first thing that I have to implement or add is a tag to the mesh section of the body. I'm going to call it body. And then I'm going to add another one to this node, which is the modifier that I'm going to use, which basically removes sections of the UVs defined in this graph here. Yeah, with this zoom, it's difficult to work, but yeah. Here I can define some blocks. You will see that once I set up the tags, this node will be linked to this mesh section. I'm going to do it right now. So I'm going to target the body tag that I created just right now. And you can see how this, by adding the tag, I'm populating the UV or this widget with information of this mesh. So now I can create some blocks here to delete the UVs of the mesh section of the body. But as you can see, the resolution is not really good because with a single block, I'm deleting stuff that maybe I do not want to delete. So I can change the resolution here. Now it's much better. I have more detail to work. So now I already know that the torso is part of the UVs, and I also know that this part here is also part of the torso, and I want to remove this one. And once I set up the parts that I want to remove, I'm going to say that this modifier is going to be active at the same time or when the shirt is enabled. So let's see the result here. If I compile, as you can see, the body has been clipped. And as you can see also here, if I remove the shirt, the body, it's fine. It's not clipped because this modifier is enabled when I enable the shirt. We also have some tools in this viewport to see what's going on. For example, if I put the wireframe, I don't know if you can see it, but if I enable the shirt, the geometry of the torso has been removed. Another way to see this, if you do not want to work with this view because you lose a lot of details, we have here another tool which allows to see what the UVs of the different mesh sections that are being added to the to this component. So, for example, now I just can see the one mesh section, which is the one of the torso. But if I enable the shirt, then you can see that the UVs have been removed. And also here I can see the UVs of the shirt that has been added. And also I could also see the UVs of the shirt, of the jacket here. So yeah, with this I covered this kind of modifier. You can use different ways to clip. Mutable has different ways to do this. For example, we have clip mesh with mesh, which allows you to clip with a volume. You don't need to have a particular UVs set up in a particular way, or you can also use texture with the clip with UV mask. You can test all these modifiers in your demos. Also, another thing that I want to explain, which is pretty difficult to understand, maybe, it's the way that this kind of things, which we call the UV layouts, work in Mutable because you can modify them. So to show this, I'm going to implement another optimization that Mutable has, which are the we can reduce the draw calls. For example, let me show you that here right now, Mutable. Or let me open the skeletal mesh editor. Maybe you are more familiar with this editor. Here you can see that we have 3 materials, 3 mesh sections, and two of them, as you can see here, share the same material parent. So actually, those 2 materials are the same, but just have different parameters. So Mutable is capable of merge those mesh sections into the same one. So I'm going to show you how to do this because this will optimize your graph. So, for example, what I want to do here is I want to merge. I want to merge this skeletal mesh section into this one. So I do not need those nodes anymore, and I just need an what was the name of extend mesh section? Yep. And now, as this is a modifier, it goes here. And also, as it's linked to this node, it will be only available. It will work only when the jacket is enabled. So also this one works as is a modifier. It works with tags. So since here I want to modify this mesh section here, I have to add a new tag to this mesh section, and this one is going to target this tag here. And now, if I compile, as you can see, everything is broken, but I will show you how to fix it. But the main point here is that if I open the generated skeletal mesh, you will see that we just have two material sections instead of one. And if I isolate this one, it's the jacket merged with the shirt. Okay, how can we fix the skeletal mesh, the textures? Well, the first thing, I also want to show you, the UVs of this new section, because it's here. You can see this new section has the UVs of the both skeletal meshes, skeletal mesh sections. So now what I want to do is, as you can see here, we are losing a lot of, first, let me fix first the texture. So the first thing that I want to do to fix the texture is quite simple, because when we merge stuff, we have to say to Mutable, to the mesh section, to the Mutable that we want to regenerate the textures using the Mutable algorithms. So we have to set the default textures to Mutable. So now if I compile, Mutable will generate textures. And for example, if I unplug the jacket, we will see that now we recovered the textures of the shirt. But if I want to recover the textures of the jacket, I have to, first of all, set this node properly by setting first reference material. What this material does is basically it populates this node with all the texture parameters that are inside the reference material. And then once I got this, I already got it here. And let me change this node for this one and delete this one. I can set the textures that will be used by the jacket, basically. So now if I compile, you will see that the jacket just looks correct. I want to mention, the problem with the UVs, because we have here a lot of empty space that Mutable is also able to fix. And to do so, we have to work with the layouts that can be set up here in those nodes in the skeletal mesh node. So the first thing that I want to do, I'm going to modify the shirt. And here in the layout editor, we will select the lot 0, that this is the one that we currently working on. So let's select this one, and we will see another tool like the previous one, where we can see the UVs of the mesh section. First of all, let's work in a grid size, in a grid resolution that matches the UVs, again, 32 by 32. And as you can see here, we can set some blocks that basically we are only use those parts of the UVs. And Mutable, once compile the editor idea, sorry, once compile the object, will repack the UVs in order to try to get as much space, as much as UV density as possible. So if I compile, you will see that now the UVs of the have changed a little bit. Now most of these parts are from the shirt, and this part here is from the jacket that we now have in a little square in a little block here. This is because we have to also set up this layout here by just changing the resolution, because what it's happening right now is that we have this layout set to 32 by 32, and when we make an extend mesh section, we are adding a block of 4 by 4. So what we want to do is add another block of 32 by 32 to not lose any resolution. And we can here we cannot pack this properly with blocks, but Mutable has another tool, another option here that allows to use, instead of blocks or rectangles, use directly the UV islands. So if I compile now, you will see that everything has been rearranged again, and we also have again the correct resolution for the jacket, the shirt, and we still have just one mesh section. So pretty cool. Another.
You don't mind me jumping in for just 1 second? You haven't been able to see it because we've been zoomed in to try to maximize the real estate here. I've been smiling ear to ear like this whole time, and actually, even the chats are going like, "Yo, this is so nice. This is black magic."
Yeah,
these are really cool tools. I haven't done much character stuff, probably a decade or so, but from the character stuff that I did do, man, I wish I had these tools then. It'd be so much nicer. This is incredible, folks. This is awesome.
Thank you. So if you like this one, you probably will love the following one. Yeah. So here, imagine that you have again, I set up another example, but it's pretty much the same. You have this character which only has a shirt, but if we open this skeletal mesh, we will see that we have a bunch of morph targets, and one of them is able to change the shape of the body. So now let's add this to our character. We are going to add a mesh morph, which is going to be the output, the input of the mesh section. And to modify this morph, we need, let's add a float parameter right here. I'm going to call it body type. And now let me disable first the shirt so you can see what's going on. First, here I have to select the morph that we want to apply. In this case, I'm going to use the overweight. And if I compile, you will see that now we have a morphing body that can change from regular size, regular type to overweight type. So now, if the problem is if I now plug the shirt and I compile, yeah, this is a problem because the body is changing, but the shirt remains with the regular size. So the first thing that you can think is, okay, let's add another the same morph to the shirt. So if I go here and add a mesh morph, the problem here is that I do not have this morph in the shirt. So Mutable, it's able to transfer data from one morph to another mesh that does not have morphs. So we can do that with a node which is called Reshape. And the input basically is with the base mesh that we want to modify. And it's going to be the input of the mesh section. And basically here, the base shape is the shape of the shirt that we want when there is no morph applied. And then the target shape is the one that we want to be morphed to. So in this case, if I compile, let's see what happens. If I compile and I move this slider, we can see how the shirt is adapting to the morph of the body without any morph. And this is really cool because we can implement more variations to our character without doing anything, without modeling another garment for each type or modeling a morph or anything else. For example, like here I have the jacket. So by just plugging this here, and also adding it to the base object and compiling, sorry. I think that I plugged, as always, I plug it this to run and compile. Yeah, that's it. I have also a jacket for each type of body. Also, we can, you can see some artifacts here, but this can be removed by just enabling the recompute normals and compiling again, and you will see that this artifacts have gone. Yeah, but I just want to mention another thing. Quick, an advice. If you can, instead of using the base body to make those morphs or those reshapes, I will use, this is a really, it's like the body, but with less details, but with the same morphs. This will allow us to have like a smooth transition of the morph and do not have, for example, here, the belly button or anything like that. So for example, then if I change the target here and the base shape, and also here in the jacket, the base shape and the target shape, and I recompile, I have to also plug the factor, sorry. You can see that Mutable always tries to explain you what you are doing wrong. And now I have a smoother transition, and if you want to see it working, here you have it. And for me, that's pretty much it. This is like the most difficult stuff in Mutable in working with those graphs. The rest is pretty much straightforward, and you can check the documentation for that. And now I'm going to hand it over to Gerard.
First off, awesome.
Oh, sorry. Yeah, sorry.
no, that's perfect.
Yeah.
I'm just again, I'm looking at chat here and pure magic. You know, there's a lot of
yeah.
this
Sorry,
will save mountains of work. Somebody's
I just follow it.
Just applause,
my script.
So,
sorry.
Yeah. No, this is so cool.
Thank you.
Yeah. Great. And then you said we were going to
me, Gerard. So
Gerard.
Perfect.
yes, I'm ready.
Let's do it.
Okay, so before I'm going to some specific examples, let me first give you a quick overview of what's going under the hood. So I'm going to start an insights trace and going to open this trace. Okay, it's running, and I'm going to do a quick customization. I'm going to open the sample, customization, and I'm going to change the shirt. And let's see what happened. So you're going to see that Mutable basically uses time regions to mark the different updates or customizations that's being done. So you can see, because we open the editor, we use plain editor, and we been over the different menus, you can see different customizations. And the last customization, which is a shirt, is this one. So you can see that this is the work that Mutable is doing. So one interesting thing is that if you search for this timer, which it's called state, skeletal messaging. We go here, and this is the scope, which is hidden over here, but you can see the bar here. Basically, this is the customization request. You can see that the user, or in this case, the UI, requested the customization. It gets into a queue, and because there was no other customization, it automatically starts. And you can see that it starts if we look for the mutable. Okay, mutable task game. You can see that this is the start of the customization, and also the end of the customization, which is the callbacks, which basically notifies the user or the API that the customization has finished, is here. And you can also see that we have another tasks, which are these. And basically, this is the work that Mutable does on the game thread. And this is important, and I want to put some emphasis here, is that Mutable is asynchronous. So what you're seeing now, the regions are basically what's run in game thread. But if you want to see the real work that Mutable is doing, which is doing async, you can always search for code run, which is basically our virtual machine. And here you can see this is all the work that Mutable is been doing. And if you want to look at the work that's been done, you can find some tasks here. It's a bit confusing to look because this machine has multiple threads and it basically splits the work on all these background workers. But you can see here that basically Mutable works async. Another point that I want to mention is that you can see that there are some time lapses that Mutable is not doing work. That's because Mutable in those time lapses is basically streaming data. So there's the misconception that Mutable, when you have a customization, you have everything loaded, and that's not true. So Mutable basically it streams only what's necessary exactly at the point that's necessary. So we keep our memory footprint very low. So let's go to a specific example. So imagine that you have a very simple example, a very simple customizable object, which is basically has a root, a component, and this component has two mesh sections, which one is the body and the other is the head. And also we have a shirt, which is another mesh section. And you can see that the shirt, you can customize the shirt because basically we can customize those two textures. We have one switch with a parameter here that basically allows you to change the image on top. And we have another switch with another parameter that allows you to modify the background pattern. So notice that basically what we are doing now is we are switching textures. But apart from switching textures, we are not doing any operation. For example, as Max explained, we are not doing any kind of texture packing. Or in another case, in the sample, you will see that for the skin color, we are doing some image operation that we're layering the skin color with other textures, with, for example, the freckles. We're not doing any of this. So you can optimize this because since you are not really generating textures, you are not operating with the textures, you are only switching. We are not interested on passing those textures to Mutable. We are only interested on making those textures like sending to Mutable. Mutable does nothing to them and passes them outside. So basically what we want to do is the texture to be in pass-through mode. So to do this, we can change textures to pass-through mode and change the type of these switches, which I conveniently already have it here. And before I compile, I'm going to show you the before and after. So we have this very nice tool, which is the texture memory analyzer. You can see here that basically these are the textures that we are generating. And you can see that in the previous case, we were generating two textures. Now, if I compile, these textures basically disappear. You can also see this very clearly Because if you go to the generated skeletal mesh, you go to the mesh section of the sheet, you can see now that we are using an asset that was already in disk. It's not generated, it's not transient. If we compare to the case before, let me just unplug this and set these textures again as mutable. I'm not going to connect, just to make the point. Compile. The textures has appeared again. Let's go to the section. And you can see now that these textures are transient, which means that Mutable has generated them from scratch. And you can see it because if you hover, it makes transient. And also, if you look at those textures on the project browser, you cannot find them because they are new textures. So another very useful tool for performance analyzer, it's the performance analyzer. So imagine that you have a very complex character and you want to test the different options. Instead of manually having to see all the options, what you can do is just set, just randomly generate a bunch of instances. In this case, for example, we are very interested on the images. And you can see that in the image column, we are generating, although the time is very low because basically we are only switching these textures, but we are still generating them because they are in mutable mode. If we go back to the graph and we set them back to pass-through, compile and run the performance analyzer again, we can see now that the time is basically negligible. So we can see also this in a more complex example. Let's go to the character, which is probably the most complex customizable object that we have. And we're going to generate a bunch of instances. So what we can do is, for example, we are going to, again, sort by image. And we are going to open one of the generated instances. And here you can see that, well, it takes time because we are generating quite a lot of textures. If we go back and we compare this with, for example, this one, which is a lot, we can see that exactly the get meshes time is much lower because we're generating much fewer textures. But not also this. Also, I want you to put some emphasis that in this instance, for example, we are not streaming the textures, and the format of the texture is also not compressed. But in this other instance, we are streaming compressions, which is much better because not streaming textures, it means that when you are requesting the customization, you are generating all the textures at once. Instead, if you stream textures, it means that you only generate the textures when they are really required by the engine. Basically, it uses the MIP data provider of the engine. So having said this, now we're going to see states, which Dustin mentioned very briefly. So imagine that you have an instance, in this case, a weapon, and you want to let the user customize this weapon on the locker. So to keep it simple, imagine that the user wants to have this sticker and wants to put the sticker wherever the user wants. So as you can see, it's not very real time. And that's because we don't have states. So by default, Mutable tries to optimize the customizable object to be as efficient as possible at runtime. But this means that it's not very efficient for customizations. If you want to really be efficient at customizations, let users do changes on the locker and be those changes really fast, you have to create states. So let's create a state. So we're going to go to the root, and we're going to add two states. As mentioned, by default, the state is most optimal for gameplay. So we are going to create a default state, and we're going to name it gameplay. And then we're going to create another state, which we're going to name it locker. But let's just be more specific, because you can have as many states as you want. So in this case, we're going to set it sticker, because we are going to activate this state only when the user is modifying the sticker, when it's selecting the the sticker gizmo and it's moving the sticker around. This way it will be much more optimal. So in this case, we're going to select, okay, the user is moving the decal or sticker location. And because we want to be very fast, we don't want to compress texture. So we're going to set don't compress runtime. This means that any texture that depends on this parameter, it will be not compressed. We're also going to disable mesh streaming. In this case, it really doesn't matter because it basically, since we are only moving the sticker, we are only regenerating the texture. The mesh will be the same. Will be disable texture streaming. We are interested on this. We'll reuse the instance textures. So this means that instead of creating a new UObject each time update is requested, it will reuse the UObjects from the previous update. And because we are on Locker and we are really close, we really don't need to see low resolution LODs. We're going to only generate the first one. So we're going to compile. And in here, you're going to see that now we have two states. We have the gameplay that, as before, it's slow. All textures are streaming. All textures are compressed. But we can switch to the sticker state. And now you can see that textures are not streaming. Now we only have one LOD. Before we were having three. And the texture, the specific texture that we are projecting, which is this one, is no longer compressed. And you can see now it's much faster. And well, that's a quick overview of what you can do in about performance. And I'm going to pass it to Pera.
Thanks, Jeff.
Great.
Dan, if we can cut to my screen.
Yes, let's get that open.
Okay, thank you. Just a quick follow-up on the performance topic Jar was talking. If you are planning to release the game for a specific target in mind, for example, if you want to release the game for Android low-end, but you also want it for Android high-end or PC, there's a setting that just works the same way with skeletal meshes, which is the quality level min LOD. This is really useful because it basically discards part of the graph depending on the settings the user are using. So if we want to discard some LODs on Android, then we can just say, okay, if Android is quality medium, I want to skip n LODs. The same goes for this minimum LOD. The mesh have it too. Just specify the platform and then just set the configuration you want to skip. This will remove some content from the platform directly, but will also be dynamic. For example, if the user changes the setting on the windows from low to high, it will automatically adjust the mesh, so the higher quality LODs will stream in as they should. And well, this is also helpful to reduce memory cost on some platforms. And talking about memory cost, Mutable has a working memory budget. This is a soft limit we have. It's something that can be changed anytime via CBAR. Let me find this CBAR working memory budget. So at any point in your game, you can just modify this budget. This comes with some performance impact. For example, the higher the budget, the more caching Mutable will be able to do, and the updates will be faster. With a smaller budget, Mutable will struggle a little bit, but will still work. As I said, it's just a soft limit. So if it has to create a 4K texture, it will create a 4K texture. But yeah, that works well to keep the budget low when generating things. So Mutable will just try to respect that budget. Now, talking about runtime and performance and all this, makes you wonder, like, do you really need to use Mutable at runtime? In all instances, maybe you just want it as Dustin said to use it as a pipeline tool. to create a crowd and then bake them and just use Mutable to do the final touches in game or for the main character. That's something that you really have to keep in mind. It's like Mutable is not free. It comes with a cost, especially, well, the editor doesn't really matter, but at runtime it's important to keep in mind that if you go all out with the customization, it might take a while to do so, to generate the resources. But yeah, with the tools we have, you just have to keep an eye on that. Now, I would like to talk a little bit about how to generate big graphs without burning yourself. Basically, it's easy to keep adding content and then just have a massive graph that you can just, well, you lose yourself there. So that's something that we have some tools to deal with. One of them is the data tables. I don't know if you are familiar with the data tables, but basically you can create a table of content where you can just keep adding rows with options and parameters like skeletal meshes, textures, materials. And Mutable converts those tables with data to a switch of options. Oh, wait, let me find that. Here. Yeah, sorry. So this node basically creates a switch. And this means that if you have 100 shirts, or in this case, the barrel of the weapon, and you create, let's say, okay, I want this barrel to be added to the rest of the weapon. Then you will have at runtime the option to switch between all the different options defined in the data table. So that's a way to scale up your graph, your options, your customization options. Another useful tool that we have right now is the macros. Macros work as any other macro in Unreal. It's just a graph within a graph. You can define here a group of nodes, behavior, and just add it to your graph as many times as you want, changing the inputs and working with that. So these are the tools I would recommend right now when it comes to like creating big graphs. But there is something else that we're working on right now, which is the skeletal mesh parameter, the material parameter, and the texture parameter. Up until now, Mutable worked that in a way that we compiled and gathered lots of resources. And then at runtime, we just use those resources using a logic to generate the meshes and the textures and the materials and whatever. The new flow we are trying to use, which is the dataless approach, is that you just customize the logic. You just define the logic in the graph. And then you define parameters that can be connected to that logic. So, for example, in game, you would have a parameter for shirts. And then you would say, okay, I want this parameter to be added to the body or to be merged with this other clothing piece or something. But you don't know what shirt you want to use. And then you compile that. At runtime, you create a new instance and said, okay, now I want this shirt and this material and these textures. And Mutable will just do its magic and just merge things. This will land in 5.8. There's still a lot of work to do, but we believe this will help a lot of teams grow big. But there's another thing that will come along with this new flow, which will be the ability to work at different levels. Right now, all examples you have seen is like we create the mesh section for everything that we want to add to the final mesh. These can be really cumbersome. For example, in case of metahumans, they have tens of sections, so it can easily go the bad route when generating the graphs. We want to add a new possibility that's, yeah, I have this mesh, I have this other mesh, merge them. Or I have this merge, I want LODs 0, 1, and 2, and just skip LOD 3. Or yeah, I want this mesh, I want this section from all LODs, and I want to merge that to the final mesh. That's what we think will be the future of Mutable, this combined with the dataless approach. And that will help a lot with, for example, the metahuman case I was talking about, but also it's like users that don't really want to go that deep into Mutable. They just want to merge things, to switch textures, to maybe remove a section or remove the body underneath the shirt. That will hopefully just make things way easier for all. And yeah, one more thing. If you're one of these games that want to release content on a weekly basis, or maybe you want to create a new DLC for the game, we do have something to help with the development, to like filter stuff that you don't want to get released or to be seen, which is the version bridge. It's basically a versioning system for Mutable. You can go to a customizable object and say, okay, this will be the version future, or will be the next release, or something like that. Here you basically can override this interface and just create your own versioning thing that will be hooked into Mutable, and will just filter content based on your needs. And I think with this we can go to Q&A. No, I'm not sure if anyone else want to
Yeah,
add something.
I've got one. That's awesome. The version bridging stuff. Like having worked in live service, that stuff is usually really hard. So the fact that it's in there is awesome.
Yeah.
Dan, if you want to share my screen, we talked about a ton of stuff today. We've got some more information. So last year at Unreal Fest Orlando and in Unreal Fest Bali, Gerard gave a talk in Orlando about just kind of the structure and basics of Mutable and things to look out for. It's a really informative talk. It's a bit more show and tell and how we use it here at Epic as well. So you can see some products that we've actually put out with it. And then I did a talk that's more of a practical first, 30 minutes getting into Mutable kind of talk at Unreal Fest Bali. And there's some links here. You can also find them in the YouTube playlist for each of those Fest branches there. And then we've also just got some other useful links and docs. So the first one is our Epic Developer Community tutorial page, where you can go dive in and get into Mutable, and they'll have some quick start stuff in there, as well as stuff that these folks have written to help community folks out with the tools. We have this GitHub link here for it's an older link, but it is a wiki style, like what do these nodes do kind of documentation that I find very useful. That's still updated. We're in the process of like getting these things transferred over and whatnot in the future, but that stuff is still there as well. So if you're curious about what a specific node does or how you're supposed to use it, you can find that in here, as well as just some like what's the intent behind some of the Mutable setups that we have. And then the last one, I kind of showed it earlier, is just a link to the sample project that we have been working in today. It's great. There's a ton of information in there, tons of things that you can kind of deep dive into and poke around with. And it also can be a great starting place for you to kind of build your own character customization stuff off of in the future. Yeah. And that's
Awesome.
it for me.
Absolutely awesome. Absolutely awesome. I wanted to thank you all. I'll leave this up here for a second so folks can grab the QR code. I want to thank you all so much for putting this together and coming on and showing this all off. This is really cool stuff. Selfishly, I think it's awesome. I think it's really, really amazing. Some of these tools. So I appreciate you coming out here to do this. And I also, chat has popped off a little bit. We have a ton of questions.
Sure.
So if you folks are up for it, I would love to jump in and do some Q&A. So yeah, let's go ahead and jump in real quick. I guess we'll start here with a pretty quick one. Can you please provide guidance on how projects that have traditional / modular characters with lots of skeletal mesh components transition to mutable?
Pere, do you want to take that one at all? Do you have any thoughts there? Or Max?
Yeah, so transitioning from having multiple components into a single one. One thing we didn't talk about is that Mutable allows for merging skeletons.
Mhm.
So basically, if you have different components, but they all share the same or a compatible skeleton, we can just merge them and output a mesh with that. So it shouldn't be a big deal when it comes to just throwing a little bunch of meshes to Mutable. That said, skeletons must be compatible. But I don't think it's a big deal to just merge things. Of course, there are cases where you want to keep it apart. For example, maybe the head. In case of metahumans, where you have a groom, that probably should be a separate component. Also for the control brick for the face and all that. But if it's like merging accessories or weapons or a backpack, that should be easy.
Yeah, and
Awesome.
just from a practical advice perspective, like if you watch the Unreal Fest Bali talk, it goes through that introduction and really start with your skeletal meshes first. Start there. That's probably the most easy way to kind of understand how the flow goes, and then you can get into your textures and materials and your atlasing from there. And the thing that you'll find a majority of time as you get started is you'll be working in one big graph, and you'll start to see, oh, this is starting to get cumbersome, or it's hard to work with, and then you explore the object groups, and then that kind of explodes into data tables. There's kind of a flow of learning that kind of happens, and the main thing is it's deep, and most likely there is a way for you to do something that you're trying to do to create a more performant character customization. Um, you just need to go find it. And hopefully we can provide some more examples of that in the future. I think a gap that I just have been thinking about as we've been doing this today is like, how do I do this from Blueprint, for example? What's that connection to the gameplay code that's really nice? And we can show stuff like that. And there is documentation and workflows for that available, but it is not widely talked about on that side. So.
Yeah, awesome. This next question's a little general, so we could probably go a few different ways with it, but can these assets be used in a production game as is, or is there any limitation to the use of these content?
I should talk with legal about this. But yeah, I think that I think that all we have the rights of all the assets used in the demos. We work with an artist, and he made those assets just for the demo. So I think that the answer is yes, but I don't know. I'm not really sure.
Yeah. That's fine. That's totally cool. What are best practices for optimal runtime performance? I'm sure that there's definitely an expense to doing some of these things. I would assume like the modifiers and stuff like that. Some of those shape, making things fit to a skeleton or not a skeleton, a pre-existing mesh and stuff like that. Certainly has a cost. What is the feasibility there with real time things like that? Is that something that you'd still want to bake down to an instance, or is there any feasibility to having that kind of runtime? Like, I don't know, maybe you run around as a character and you absorb things and you get bigger as that goes and stuff like that. Or
Gerard, do you have any thoughts there on like just some practical tips?
Yeah, basically, um, usually what's more expensive are the textures. So if try to avoid doing as fewer as possible texture operations, because if you keep adding more texture operations, the customization is going to take really long. So try to keep it simple. The thing with Mutable is that you only pay the price once you're customizing. Once it's customized and you already have the assets, you don't pay the price. They are normal Unreal assets, normal skeletal meshes, normal U textures. When you pay the price, it's only when you're customizing and creating those. So try to keep the number of operations as minimal as possible. If you have to some texture operation, maybe move it to a shader. If it's only applying a color, you don't need to apply a color directly in the texture. And basically that's it. Keep in mind also to enable streaming. It's very important, especially in 5.8, we polished streaming, and texture streaming it's working really well, and texture streaming also has been working really well for the past releases. So it's also a good way to offload the work and not pay the work if you really don't need it.
Right.
Yeah, I want to add something into that.
Please.
You said something about the materials, Gerard. That's true. That's if you have to change a color, there's no need to create a new texture with the color applied. Just for that, because maybe if you don't touch the color from the texture, you can reuse that texture across multiple instances. And that's something that Mutable does automatically. So if you have 100 instances and some of them use the same textures or have the same parameters, they will use the same resources.
Right.
And the last thing I'll add is if you're, coming into that kind of like character tech artist role where you're building these systems, I would highly recommend getting comfortable with both the debugging tools that were in the mutable graphs that Gerard showed, but also getting familiar with insights. So Unreal Insights is really a key tool for us. And there's a bunch of talks on how to use it. A lot of them it's not just for programmers, basically. I recommend all TAs and folks that are doing this type of work to jump in and start to learn and how to read the graph and how to understand the flame graphs, and that way you can do those A/B tests and you can like start to understand your performance metrics through that asynchronous operation. Or if you forgot to turn on mesh streaming and you're like, why does this thing take 200 milliseconds to build? Oh, and it's blocking my frame. That sort of thing. We want to avoid that, and the team has put in a ton of effort to make that easier for folks. But it's still possible to do those things if you don't have the right option set. And on the tech dev relations team, where I work with people answering questions and things, this is right now, as folks are getting into this space, one of the most common questions that we run into is like how to properly turn on streaming and stuff like that. So,
right. There's another one. Is Mutable multiplayer friendly?
I can answer this just from a historical context perspective. So, the way I would design a mutable character customization system in a multiplayer context is the clients are going to do the work. So, if I make a customization and that data gets transferred over the network and then your client does the work, you need to consider that timing. We don't do anything in the mutable like system today that handles replication or making sure that stuff is set up in that networked way that I'm aware of. So you have to do that work as well as hook it up to your backend if you're a live service game. That is a caveat that I often give to folks, that glue to your gameplay code and to your services code to handle that is the work that you have to do. For the most part, it's relatively straightforward. You just say, this is the customizable instance and its parameters that I want to apply on this character, and you need to send that over to the network in some way, shape, or form. But just keep in mind that when you do that and how you do that is really important because you want to basically do it on the finalized version of whatever it is. Because otherwise, if you're sending that much data over the network to a different client, you're going to be paying a pretty large network cost as well, on top of the performance cost that you're doing for customizing it each time. But again, we don't, and Barry, correct me if I'm wrong, I don't think we support anything like that in the system today, because it is more of a client side visual thing.
Yeah. No, and that's one of those things, like it should be considered too, right? That like this kind of these considerations you would have to have anyways, right? Like this isn't just like a mutable specific consideration. Mutable
Yep.
provides a lot of options for, client side stuff, and then yeah, you have to figure out how you're going to replicate that and what kind of data you're going to send when and all that sort of information. So not out of the box, but definitely compatible, just with some work.
Yep. Yeah. The way that I've built these types of things in the past is usually I have a manager that handles transferring the data at the appropriate times and then building the customizable instance at runtime if I need to for that character, usually tied to player state in some way, shape, or form. So if that helps you folks to kind of get a framework of how to think about the problem, that's awesome. But yeah, there's some learning to do there.
Sure. Yeah, this is a quick reminder for anybody who's watching right now. If you joined the stream a little bit late, if you have any questions that you'd like to throw at the team, we still got plenty here, but if you have any more, we'll try to get to them. Just do question in bracket followed by the question that you have, and we'll do our best to get through them. We're actually making really good progress time-wise, so you guys are absolutely killing it. Another question we have here was, we were trying to bake out different size uniform scale models and found there was no way to create a manipulation transform in the graph. Any other suggestions on ways to approach something like this?
Yeah, there's I can think of two things. The Yes, there is some missing capabilities there to do that kind of uniform scale stuff. Usually, we handle that post graph update. So the way that Mutable generates a character is in your active blueprint, you have your skeletal mesh component. That's what actually all of the Mutable data gets pushed into that from the customizable component that's underneath it. And then you manipulate your uniform scale for those components post edit effectively. So you can also do other things too, like a metahuman, for example, is Y facing forward, and you want it to be X facing forward. You can do that in that layer, in the blueprint layer. So applying that uniform scale, I would do it there. We have some other tools as well, called where you can take like pose assets and do stuff with it. It depends on the use case there, because um, if you do a pose asset where you're manipulating the shape of the bones for the output of the character to be different for whatever reason, you'll need to take into account like mesh stretching and things like that. But it is possible to use a pose asset to do some of those things. And then that can also be blended as well with a float. So I talk about that a little bit in the talk that I did for Bali in regards to a car, to get the like wheels in the right spot and stuff like that. It's not quite the same as like a uniform scale, but it is possible. But it is not a we don't have some direct specific tools in the system today to handle those things that I'm aware of. So.
Right. When updating customizable skeletal mesh component, are there ways to not infinitely create DMIs? In other words, when changing a color value, we can see a new DMI has been created.
I'm not sure I understand that particular question off the top of my head. Maybe we can get some clarification of what a DMI is in that regard, because I think that's just the missing component to understand it.
Sure. Yeah, if you're still here in chat, please clarify that and throw the question in front of it, and we will get to that as soon as we can. Will this character editor setup replace the mesh variable in character blueprints or work alongside it?
I think this is a work alongside it system. So kind of like I mentioned, I'm not sure what the mesh variable thing is off the top of my head. I have two little kids. I'm a little tired. But most of the time with Mutable, the way that things generally work is you have your instance and it gets pushed into a component on the blueprint. So if you want to mix and match things, for example, you have like a customizable instance and then you have a hard-coded backpack inside of your character blueprint, you can totally do that. That's fine. And all the other systems that we have to do things like leader pose component, where the backpack is following the animation of the customizable instance that you have, or you want to attach a sword, for example, or all those other things. That stuff all works. What happens is the mutable gets created for the frames that asynchronously, kind of like Gerard showed. And then it updates that skeletal mesh, and then all the updates for attachment and propagation and stuff happen like normal through the skeletal mesh component system.
Right. Right. Does the Chaos clothing system recently released work alongside Mutable, or do they have any conflicts?
Saturday and Max, I think you guys might be the best person to take one of these on.
Maybe Gerard.
Yeah,
You have
Gerard,
been
maybe.
working with
Yeah, maybe.
That's my
recently.
experience.
We have a close support, but I'm not sure with the new release of the Chaos clothes. So I might have to take a look. But yes, what we support currently is basically, and especially in the latest version, the upcoming one, the 5.8, supporting of different sections that are basically closed sections. We allow you to merge them.
Mhm.
So yeah.
Perfect. Will we have some automated way to handle overlapping meshes? Removing mesh blocks is hard to set up manually for many mutables.
That's
a good question.
another way. It's not there yet. We've been thinking of something, but it's still in the early stages. So yeah, like we would like to have something like remove everything that's not seen, but it's not easy.
That's not that easy. Yeah, I think that we have a lot of meetings related to that, and work on how we can face that problem, but we don't have a clear way to do it.
Doesn't seem like a simple solution.
No, it's like we have to craft one. It's not.
Yeah.
There are no papers on that.
Yeah. The other question was, can we unbake at runtime? Let's say I have a baked NPC, then I loot him and get his body armor. Can we swap to a non-clipped body at runtime with one without the armor? Or is that something you'd want two instances and you kind of flop between?
You could modify the instance at runtime. You're going to pay the cost of that, so it's not going to be instantaneous. Uh, So consider that you're gonna have that performance adjustment of like I've changed the instance. Now it's doing all this work again. So there's that. But depending on how your mutable character is set up, right, you can easily hide those subcomponents in the normal ways that you would normally do it. But if you are being really optimized with a character and baking it fully down, you're gonna end up either needing to have a separate instance that you swap to that's already been calculated, so to speak, or pay the cost of like removing the jacket, removing the shirt, whatever makes sense for your game. So
No. I probably have the easiest question of the day, but correct me if I'm wrong. Could the system be used for things like tattoos, paint, makeup, etc.?
Also,
Yes.
we have some examples in the sample. We add tattoos. You can move them. We have also makeup. So yeah.
Perfect.
another
Are there any? Oh, sorry.
I was going to add just one more thing in there too, tied to all of those like projection-based techniques that Max is talking about. Another common problem with this stuff is I have like a sleeve and gloves, and I need to tuck one into the other or anything like that. There's similar like placement-based tooling to like shrink parts of meshes into other meshes and things like that. So you can like create the perfect interpolation for that stuff too. And it's got a similar vibe to those texture projection tooling. So
Perfect. Perfect. Are there any recommendations slash upsides to using Mutable to bake in a weapon attachment onto the character? And if so, would a weapon attachment be doable incrementally without a rebuild?
you could. So just sorry, I'll jump in. From a gameplay perspective, if I were building this kind of setup, you could do that if you absolutely needed to. You could pay the cost of like bringing the weapon in, binding it, extending the mesh of the character to attach it to the hand. Kind of, there's a bit of work there to make that efficient and easy. Um, but I think in general, if I were to recommend something, if you aren't that performance optimization that you're getting is pretty minimal in the grand scheme of things. So if you can afford the weapon, that is maybe customizable to be a separate attachment. That's what I would recommend. But if you had to bake it all down into one skeletal mesh, that is possible and mutable. There's some content setup things that you would need to do to make that work properly, just to make sure that, like positionally it's in the right spot. There's a modifier that allows you to shift mesh position. It's really for minor adjustments of mesh position stuff, not really for like full placement of weapon in a hand. You could, but it's really hard to do right now.
Right. Right.
Yeah.
Sorry.
No, go.
Go ahead. Sure.
One thing that I want to add is that if you need something to be really tied to gameplay, probably it's best not to do it with Mutable because Mutable is asynchronous and the customization might take time. So if you pick up an item and you need to see that it's been picked up immediately, probably it needs to be its a separate component and do it in blueprints.
Mm-hmm.
Yeah, I was about to say the same. It's like if you have to switch between weapons, just keep it a separate component.
They can be their own instances and have their own
Exactly. Yeah. It's
customizations to
just that.
them. But yeah, it's probably faster and balance of performance versus gameplay to have them be those separate instances.
Right. Another question we have was, I have an asset with 4 mesh states: default, no gear, left gear only, right gear only, and both gears. Can switching between them be done with only mutable or using enums/DA required?
I don't know
Pretty
that one.
specific question.
Yeah, I think that the unique way to switch between states is using the API, but outside Mutable, Mutable does not have a way to switch between states right now.
Perfect. Will mutable work with nanite skeletal meshes?
That's a good question.
Yes.
That's a very good one.
Next to the auto clipping.
No, that's something that we've been looking into. We had some prototypes, but they require a great integration with the nanite itself. So it's not a simple task
Right.
to make it work. Yeah.
Can mutable be used with C++ or Python?
Yes, both. And everything it's exposed, both C++, API, blueprints, blueprints to Python. It's basically the same. Everything exposed to blueprints, it's also automatically exposed to Python.
Beautiful.
Yeah. And if you don't see something exposed too, that you might need for whatever reason, raise it up. This is the type of workflows that we'd like to see more of. We admittedly, we do our best on our side to support these things, but sometimes we don't catch everything. So let us know, and we might be able to find a way to get it exposed.
Perfect. This one might have a couple different answers, so we'll see how we do. What is a good scenario to actually use Mutable, and why choose it over current methods?
So let me start. For example, if you have a character, which the combinatorial explosion of customizable parts is not feasible. So you have hundreds of helmets, hundreds of shirts, hundreds of trousers. You cannot create permutations and create unique meshes for all of those. So that's where Mutable shines.
We in the past, I've built multiple paper dolls across multiple games, and something like Mutable is a dream because coming up with the idea just to handle clipping, like just mesh clipping and overlapping meshes, was not something that was really easy even in those previous iterations. And so when you think about the idea of like a character customization or a vehicle or weapon or anything that uses skeletal meshes, and you need to take one piece and attach it to another piece, and you want to be as efficient as possible on the rendering side of things or the skeleton side of things, that's just a great use case. Um, Another thing that might be useful in the future um, is things like we've seen people exploring things like, oh, can I use this to make like a plant builder? Like it's not a character, but it is a character, and I'm gonna export, this plant that has a physics asset that I can bump into or whatever. People are exploring those things, and treating it as a combinatorial content tool, to export efficient meshes. Um, and so I would recommend one, getting in there and diving in, but two, exploring how you can use it in your project beyond the typical character customization approach, which is really what this has been developed for. So,
Right. For the morph target transfer, behind the scenes, is it doing nearest point type transfer? Mainly trying to understand, just to set it up properly.
Yes, right now it's using the closest point, but we do have another algorithm which would use the RBF style approach, but that's work in progress thing.
Perfect. Would you recommend using virtual textures as input textures? Will Mutable take advantage of virtual textures to update them in tiles to keep lower memory footprint?
Yep.
Okay. Mutable right now just supports virtual textures as pass-through. It's true that it's interesting to just, instead of packing textures together, maybe use a virtual texture instead. And that's something that we may want to do in the future. It's not for every project because not everyone can use virtual textures, but yeah, that's a good tool to have.
It's like they have like our wish list
Yeah.
because they are asking all the things that we want to implement.
Yeah. Would you use child object for every clothing piece, or group all shirts in one graph and use an enum parameter to switch between them?
I
I
was just gonna say
I would try to use
preferentially.
data tables instead.
Yeah.
Okay.
And data tables, or if you
Or a
join
parameter.
Mutable in 5.8, skeletal mesh parameter.
Yeah, but also depends the number of people that it's working on the customizable object, because then you can have conflicts. That's why we have the child system. But yeah,
I think
Right.
a good litmus for this is, generally speaking, trying to keep your functions of your graph, if they are going to be the same for every type of skeletal mesh, the skeletal mesh variable stuff and the data tables are a really good workflow. If you have a lot of very custom assets, for example, this skeletal mesh has, five material things, and this one has two, and this one has three, and you don't build your content very much the same way at all. The child object approach might be beneficial because you need to handle those objects differently per graph. You need to do custom graphing to handle them properly. And so that might be the use case where you go the child object approach versus the data table approach. The better your, I will say, the more consistent your content is as an input, the more efficient you can be with your customizable object graphs and data tables and other workflows in there, and therefore more optimized for the construction at runtime if you're doing runtime based stuff.
Right. Awesome, awesome. In Mutable, when building modular characters where different parts use different physics assets, example, hair, shoulder pads, does it require a single unified skeleton containing all bones?
No, no. As I said, well, as I mentioned earlier, we are merging the skeletons of each part that's contributing to the final mesh. But not just that, we're also merging the physics asset of that part. So if you have two meshes with different skeletons and with different physical assets, Mutable generates a new one with a single skeleton and a single physical asset.
That's so good. That's awesome. That's awesome.
We've had a few folks as well. As soon as you get into that section, some questions that crop up right away when we get to the anim graph side of things. One thing Mutable doesn't do, and you have to handle, is when you're doing all those mesh merges and you're doing something like, okay, well, I have this R-band node inside of this anim graph to handle bouncy hair, for example. Then how do I get that together so that the anim graph can do the right thing? Mutable doesn't try to combine anim graphs. That's not possible. So that's where that metadata comes in, so that you can take all the stuff that we're building and combining together and then handle it in your graph with things like linked anim layers or um, uh, the skeletal mesh, post-process anim BPs, or things like that as metadata to apply to your character or to those meshes properly. So keep that in mind that there's still some work on that front that you'll have to do to make sure that all of your animation data is playing correctly on those things.
Makes sense. Makes sense. Is it possible using the Mutable system to create styles like a sim game where you can place cloth by type of use, like everyday cloth, gym cloth, swimwear, etc.?
I don't think so, because it's not about you're usually taking content that's pre-built and pulling it together more so than you are trying to, like a substance graph, like generate new like material based type things. So I think if I understand that question correctly, um, that would be a different tool set. But the output of that tool set would be input in the Mutable, for example.
Yeah, if I understand correctly the question, I think that you can achieve something with metadata. For example, you could add information to each garment, or for example, this garment is for gym, this one is for daily, I don't know. And then, as you said, you will have to create your own tool to like sort or filter the options. I don't know if I understood correctly the question, but
Will the clip plane and morph node support other shapes for morphing other than just an ellipse?
Good question.
Justin, you want? There's
No. That's not for me. That's for you guys.
So there's a clip deform node,
Right.
that instead of having a plane and an ellipse, just takes in a mesh. So if you have a belt, for example, you can add that belt to that clip deform node, and it will shrink the body to just place the belt on top. So that's the thing we have now. It's not a clip plane, it's a clip deform thing.
Yeah, and I think the reason Pere mentioned it to me is I think we fixed a bug like what 2 days ago with it or something
Yep.
like that. That'll be in the next release. So yeah.
Awesome. This actually seems to kind of piggyback off of that previous question, which is for the clip plane and morph node, will there be a visual debug to preview what the ellipse morph looks like?
I believe that exists with the node today. I think I have to double check. But I think if you click the node, it'll display the mesh itself and then show the actual morph happening. You might have to hide some other parts in your graph to kind of see it. But I'm pretty sure there is a like preview aspect to it, but it might only be in the customizable object itself, not the instance or elsewhere and where you might need it. So.
Right. Can Mutable be made to run fast enough to do a wound/damage system?
Wound/damage system is like cutting
like-
an arm or something.
Yeah, like maybe you shoot armor off, or there's actual physical wounds from attacks. Maybe
Physical wounds, yeah, sure, maybe just like a texture thing or kind of deform, maybe, yeah. But cutting arms and generating new meshes, that's not supported yet. We have it in our wish list, but it's like way farther down the road, so no.
The idea of like, I have this thing in my head, this workflow that I don't think we've ever tried of doing like, there's a node, it's a projection layer node, basically where you can add new layers to project onto a mesh. You're generating, to what Gerard was saying earlier, you're going to be generating a new texture, so it can be costly to do that. But I have this idea in my head that you could like add a new layer for each cut and like apply like a gash texture. It'd be expensive. And I don't know if you can do that at runtime, but there's something there potentially. But again, the cost generation for textures is high, so you'd want to be careful.
Right. Down to a couple ones here, which is actually perfect because we're just about out of time. Can morph to different body height, for example, tall giant to dwarf? My supervisor is very upset. Sorry about that.
If I'm not mistaken, but correct me, you can, with the reshape, you can also reshape the skeletons.
Yeah, that's correct, yeah.
Perfect.
Yeah, the only thing is that maybe the result won't be that good if you stretch the limbs or something. It's like, not sure if that will look good, but yeah, it's possible.
You got to consider the source assets when doing something to that extreme.
Definitely try it too. This is an area that we would love to hear feedback on as well. We just need more folks trying these things out and going through the process and dogfooding it with us.
Perfect. Would you define Mutable to be more suitable for like high-end hardware, considering the potential draw call savings from reducing the number of skeletal meshes? I guess it depends on the use case, right? In this instance.
Well, just to give a quick example, Mutable is being used quite heavily in Fortnite, and Fortnite targets all kind of platforms, so it works.
Yeah. I imagine it's something that can be as complicated and efficient as you're willing to kind of put in the work to make it, right?
Yeah, I think that's where the previous recommendation of, getting into insights and checking your performance metrics and doing your platform performance testing is always going to be key. And you'll probably find instances pretty quickly on just with basic settings where you can get some better optimizations like Gerard and Pere kind of pointed at there with platform specific things and whatnot.
Right. Yep. Awesome. We actually managed to get through them all, that was like almost 2 pages full of questions. So that was great work there, folks. That was wonderful.
That's awesome.
And if anybody watching has any other questions or anything that we didn't get to here, or maybe you watched later, you weren't able to attend us live, please leave a comment. Let us know. We're more than happy to to answer questions even after the fact, and we'll do our best to get to them. I have one more question for you. It's a bit of a live stream staple, which is if you had one takeaway or one bit of advice that you would give after all the amazing stuff we've covered today to the viewers, what would it be? Probably the most difficult question I could ask.
Yeah.
I can start. I mentioned this, I kind of touched on it a little bit earlier. Mutable is complex and deep, and there's a lot to get into there. Start small, but definitely I would highly recommend if you're building a game that has a customizable character in it or customizable NPCs, explore it and see if it works for your project, especially from the performance profile perspective. It takes a while. Give yourself time. You're not going to know it in a week. You might get, prototype stood up in a week, and hopefully, the links and stuff that we showed earlier can make that faster. But give yourself time to explore it because there is a lot there and there's a lot of opportunity there because of it. So,
yeah. I will give the same advice. Like, you have to dedicate time to learn how Mutable works, and once you know how it works, it's really easy to, for example, make a character. Those examples that I show you in the presentation, I made them in 2 minutes, 3 minutes. It's like you have a full character in just a couple of minutes. So, but you have to do what you are doing because you can do things wrong, but once you start to dominate it, it's like really easy to use, and you can generate amazing stuff. We've seen people using it, generating things that we didn't know it was capable. We thought it was capable to do it, but yeah.
Absolutely.
You have to try it, yeah.
Yeah.
So, yes, I would just keep performance expectations realistic. So don't expect to have a crowd of 100 characters being fully customizable in the scene, because it will not happen. Well, it will happen, but it will take a very long time to generate them, and probably only on high-end platforms, not on low-end. So just keep expectations in mind.
Yeah, just don't wait for the last minute to check performance. That's key.
That's good advice for anything. Take that away from all Mutable, all stuff. That applies to everything here.
Yeah. And just for the future users or people that want to play with it, we have in mind plans to just reduce the learning curve because it's quite high, as we said. But we're working on making it easier for all. So
yeah, and
look forward to that.
Yeah, and it feels like one of those things that, like, you have that little bit of a learning curve to get acquainted with the tools, and then there's going to be that kind of initial setup. So there might be a little bit more like front end work, but just from what I've seen here, I can already see the countless hours of of savings of times just for the rest of that pipeline that these tools allow you to do. I mean, just simply being able to combine two meshes into a single texture atlas in other DCCs would be a whole process, and you did it in a couple minutes, which is awesome. So
nice.
Perfect. Well, that is going to wrap it up for today's Inside Unreal. A huge thank you to our wonderful guests for joining us today, and a huge thank you to all of you for watching as well. The show would not be what it is without you, your time and your questions. And if any of you came in part of the way through the show, we keep all of these sessions available on VOD form on our Twitch and YouTube page. So feel free to come back, rewatch them. I know I'm going to absolutely come back to this one because there's a lot of great information, and I never absorb it all on a first watch. So You can also keep up with the latest news, shoutouts, and other cool information on our socials at Unreal Engine. And if you haven't already, come join us on the EDC or the Epic Developer Community, where we have our documentation, tutorials, both from the community and Epic staff alike, forums, and so much more. So one last huge shout out to our wonderful guests here. This was amazing, and I can already tell. Couple updates from now, we're going to have to bring you folks back on to show us some of the cool new tools. So.
So thanks, Dan. It was awesome.
Perfect. Awesome.
Thanks.
Thank you.
Well,
Thank
thanks
you.
everybody, and we will see you next Thursday. Take care.